What if I told you you can get very close to something without ever touching it? That's the idea of and foundation of calculus. Today I will show you how limit and derivative actually work in a way you'll never forget. Hi everyone, it's Rich again, and today we are going to discuss limit and derivative. Let's begin. What comes to your mind when the word limit is mentioned? I know what you're thinking. You are guessing the farthest one can go, and you're absolutely right. But allow me to shape your understanding of limit in mathematical context. That is, limit is about what value a function is approaching as the input gets closer and closer to a certain number. Let's take an example here. Imagine a boy here walking towards what? A door. Okay? As you take a step closer and closer to the door, even though you haven't reached the door yet, but we know where you are heading, and the heading value is what we call the limit. The heading value is what we call the limit. Okay, another example is limit as x approaches to 3 plus what? X. Using the idea or the analogy of the door example we did earlier on, what the boy is approaching in the earlier case was what? The door. In this case, what the boy is approaching is what? The 2, which is what? The limit. And what we will get when we put these two inside this, that is going to give us what? The limit. The heading value, which was what? The limit. So if you put 2 inside this, you are going to get the limit. You are going to get 3, plus 2. That one is going to give us what? 5. And this was the heading value. Derivative, on the other hand, derivative measure how fast something is what? Changing. Or in simple terms, the rate of change or the slope of what? A curve. Now, let's consider this example. Let's say we have a tap here. And the water is draining from the tap into a what? A container. Okay? The rate at which the water drained from the what? The container to this container is what we call derivative. Now, imagine every 60 seconds, 100 ml of water is drained from this to that. Then derivative is going to give us what? Derivative is going to be what? Volume of water over the time it takes. Okay? And this one is going to give us what? 100 over what? 60. Okay? That one is going to be 1.7. Okay? 1.7 ml per second. This is what we call derivative. The rate of what? Change. From definition and example of limit and derivative, one cannot help but ask, is there a connection between limit and derivative? And the answer is a big yes. Now let's establish this connection. Derivative is defined using limit. With this connection, limit deal with what? The interval, whilst the derivative deal with what? The change. And combining both of their functions, we are going to have f of x, let's say f of a is equal to limit as what? H approaches 0, then get what? F of what? A plus h minus f of what? A all over h. This limit. This is what? The connection between derivative and limit. Here we are checking how function changes over a very tiny what? Interval, which the interval is what? 0. Very tiny. The interval is what? Approaching what? 0. As the interval approaches towards 0, we get the exact rate of what? Change. That's the exact what? Derivative. So derivative can be used to find what? Change, velocity, acceleration. But once we introduce limits, that one we are going to find the instantaneous measurement. We are going to find what? Instantaneous velocity, instantaneous acceleration, and so on. That brings us to the end of today's lesson. If you found this helpful, please subscribe and hit the notification bell so you don't miss our upcoming videos where we'll dive deeper into derivatives. This is Mars Physics Bridge, and I am Sir Rich, your guide. See you next time.